Hey, what's up guys? My name is Cherno. Welcome back to my game engine series. So, last time we took a look at the whole context thing, creating a graphics context specifically in OpenGL so that we can actually do some rendering, and we kind of explored how it would be different across all the different rendering APIs. Definitely check out that latest video if you haven't already. And today what we're going to do is this is going to be an intro to the next few episodes. So over the next few episodes, we're going to be building up some sort of rendering API. I was originally going to do some kind of actual renderer class, but I don't think that's quite necessary now. It's kind of going to be a boring episode as well. I didn't really want to do that. Last time we kind of almost had this glimpse of hope that we're going to render this triangle, and we never kind of got there, and I've been kind of feeling bad all week, to be honest. So what we're going to do today is actually render a triangle on the screen. Not using GL or GL don't worry. We're going to do it properly. And then from there, like the reason I kind of thought that would be a good idea to do in this kind of episode is because that's going to kind of lay the foundation of what we're going to do the next few episodes, so that you guys who aren't kind of familiar with graphics already will have a little bit more context. See what I did there? Graphics context like last video, watch that. Anyway, you would have a little bit more context as to why we're going to be creating the classes kind of for various kind of rendering primitives like vertex buffers, index buffers, vertex arrays, you know, shaders, textures, that kind of stuff, because that's where this is heading, right? We need to build up some kind of API, and then next week, I've got quite the video for you guys next week. You gotta hang on though. But next week, we're actually going to be taking things a little bit, we're gonna make things more exciting and have a more exciting goal to actually work towards. So that's kind of the idea. I thought that maybe we could build something really simple in this episode, just kind of straight, like kind of raw OpenGL calls right in our application class to show everything that we need to then take and move and abstract into kind of classes, so that way, instead of just spending 3 episodes building classes and not even having a triangle and then only having it come together in the end, we kind of have it immediately, and then we kind of sort everything out as we go. Before we jump in, I just want to take this moment to thank all the patrons who made this series possible. Patreon.com/thecherno. Great place to actually support this series. You'll get many benefits, such as videos early. I think the videos early thing is probably going to resume next week because I'm still kind of recovering from my honeymoon. And by recovering, I mean I'm still kind of trying to like sort everything out. I mean, I've just moved into my kind of renovated apartment and all of that stuff. And so because of that, I need to still kind of sorting everything out with work as well. And there's so much stuff going on. But next week, I think that should be back. And then also you'll get access to the Hazel development branch, which is like kind of my private dev branch where I just push code like pretty often. And that's kind of where you'll see this engine a lot more advanced with things like render command queues and all that stuff already kind of implemented. And in fact, because a lot of the stuff on that development branch is actually a lot more advanced, some of that stuff won't make it into the series for like months, if not like a year maybe, because we've got so much more to cover. Like, it's almost like the Hazel dev branch is me just having fun playing around with different development kind of ideas and actually just jamming in everything as I would as a software engineer. Whereas this is more of like an educational series that kind of goes a little bit of a different direction. Obviously, in the end, they should be identical, but it's like the parts are very different. So definitely check that out if you're interested. All right, back to this. So that's kind of what we're going to do. I'm just going to jump in, write some OpenGL code. Off the top of my head, to be honest, I've got no reference at all, but I'm pretty good with OpenGL, so hopefully we'll get a triangle up and running in kind of a dodgy way that may not work on all graphics drivers. That's how you know this video is going to be exciting. But hopefully, like, I'm really interested in you guys to actually try this out and see if it works, and let me know in the comments below. Anyway, let's just jump in and take a look at what we have here. All right, so this is Hazel, it's a little game engine we've been working on. If I just launch it, you'll see we have kind of this pink, clear color here. That's the first thing I kind of want to change. Let's make that maybe black because, or in fact, and that's white by the way, but let's make it maybe like 0.2 or something like that, like really kind of dark gray. It's probably not that dark, just so that we can have something a little bit darker, because that pink's beginning to annoy me. Yeah, something like that, maybe even 0.1. I'm not going to waste too much time on this, but I do want something fairly dark. And then so this just kind of will make this a little bit more bearable, I think. There we go, that's pretty good. And now what I want to do is kind of draw a triangle in the middle. So if we kind of move this ImGUI demo out of the way, I just want a triangle kind of in the middle here, right? And so to do that, what I actually need, if you think about OpenGL and think about what we actually need, and this is, by the way, is a great time for you guys to actually check out the OpenGL series. I have this entire playlist of videos. This is called the OpenGL series. It's where I actually teach kind of OpenGL by itself, not necessarily in a game engine, but just how to actually use OpenGL to render graphics. By the way, that series, I know I haven't uploaded a video in so long, but I'm about to jump back on that train since we are actually doing rendering stuff in Hazel now. So that video, don't think of that series as like, oh yeah, watch, that was a thing of the past and now Hazel's taking over. No, that series still is a standalone good series where I actually explain how rendering and how OpenGL works. So definitely check that out because that will help clear this up. What I'm about to explain now, there's going to be a bit of overlap between the series. I'm not going to dive in too deeply into graphics in this series specifically, just because of course this is about kind of general game engine, not necessarily a graphics series, although I can't just talk about rendering and not actually talk about it. But what I'm saying is that a lot of these things, if you're not very familiar with graphics and you want more information and you want to even maybe start writing your own code for this outside of just waiting for these episodes to come out every week, you have to check out that series because there's so much good stuff in there and I'm going to keep adding to it very soon. Alright, anyway, so what you would already know is that there's many components to kind of rendering a triangle, right? I mean, we essentially need, let's just kind of jot these down. So we essentially need something called a vertex array that's required for the core OpenGL profile. From like version 3 point something or higher, I'm not sure. We need something called a vertex buffer. We need something called an index buffer. We need something called a shader. I think that's probably about it, to be honest. These are kind of the four things that we absolutely need, right? But what we can actually do is, because if you think about the amount of code we need to write all of these three, not much. This, a lot, right? We need to write a vertex shader and a fragment shader and all the code to actually compile that shader. That's a lot of work. Don't really want to do that right now, okay? We actually don't need that because GPU drivers typically supply kind of a default shader that they will actually activate if you haven't done anything at all. So not every graphics driver will do this, but a lot of them will. And in fact, I'm on this laptop right here and that's got both an Nvidia GPU and an Intel GPU and they both seem to actually supply these. So definitely at the end of this video, try out this code I'm going to give you and the code that I'm going to write here. You can even just clone the Hazel repository and see for yourself. And just let me know kind of what GPU you're running and if it worked or not. We might even put some code in to actually get the actual GPU vendor out so that we can check that. All right, anyway, vertex array, vertex buffer, index buffer. Those are the three things that we need to create in order to actually get a triangle rendering on the screen. We don't need any shaders, we don't need any maths. But this is kind of what we need. So let's just get started. What I'll do is I'll go to the application file here, and I'm going to create basically 3 unsigned integers because they're going to be the IDs, right? So we're going to have our vertex array, our vertex buffer, and our index buffer. All right, let me just move this output out of the way. And then what I'm going to do is over here, just going to create all of them. So we'll get rid of this. This is the constructor for application, by the way. I'm definitely doing this after I create the window because that's where, of course, we create that OpenGL context that we did last episode. So we'll go ahead and type in GL gen vertex arrays. We want to generate 1 vertex array and then put that into there. Then we'll bind it. So we'll just bind vertex array. Then we're going to do the same thing with our vertex buffer. So we'll go ahead and generate a vertex buffer and bind it as well. So GL bind buffer, GL array buffer is the target type, and then vertex buffer. All right, and now we need to actually populate it with some data. So we need to create some vertices. So I'll create this float array called vertices. We'll say 3 times 3. So we're going to use 3 kind of 3-dimensional coordinates, and we're going to have 3 of them. So 3 vertex positions over here. So we'll have negative 0.5f, negative 0.5f, and 0.0f. So this is kind of one vertex, right? It's a 3-component vector, basically. It's like a 3-dimensional coordinate in space. Now, by default, if you don't have any kind of projection matrix, or you're basically not transforming your vertices by anything, right? You have kind of the default clip space that OpenGL deals with, which is basically -1 to 1 in every axis. So -1 to 1 x, -1 to 1 y, -1 to 1 z. That's kind of the rendering kind of space that you're dealing with. Every point eventually gets converted to that. Obviously, when you have 3D models, they might be in some kind of different scale, completely different space. You might have vertices that are 200 or something like that, right? That's because it goes through something called a projection matrix, which eventually converts it into -1 to 1 anyway. Since we're not doing any kind of maths, we basically are in that space already, which is why the edges of the screen are basically -1 to 1, okay? So -0.5 is kind of a quarter of the way from the left side of the screen, right? And you'll kind of see this when I actually draw the triangle. So we're going to go counterclockwise, right? Anti-clockwise here with our winding, because that's kind of the default winding. So this is going to be 0.5 f. So this is on the other side of the screen. We're kind of drawing a few points. If I just open up paint here, to kind of show you, this is kind of, pretend that this white canvas is our screen, right? Essentially what we're dealing with is 3 points that we're drawing. We've just drawn one about here, right? We're going to draw one more here. That's the second kind of coordinate. And then we're going to draw one here, okay? And then obviously when we render it, it's going to kind of fill all of that in, and we're going to get a triangle on the screen, okay? So this is 0.5, meaning that it's kind of, this is, -0.5. I'm not going to pretend to kind of do this stuff live for you guys. But that's -0.5x, that's positive 0.5x, and that's going to be 0x, right? Because it's right in the middle. And remember, this is kind of, this edge is -1, and this edge is +1 in the x-axis. Same thing with y, right? This edge on the bottom is -1, this edge is +1, okay? And then for z, we're leaving all of them just at 0, all right? 0.5 or -0.5 would work as well, no difference. We'll do 0.5f, we'll do -0.5f again, because the y, of course, of that second point is the same as the first one. And then finally, we'll do 0.0f and then positive 0.5f. So this is kind of that topmost point over here that we're rendering, all right? So there we go. Now we need to actually upload this data to the GPU, because obviously right now it exists in the CPU. So to do that, we'll just type in GL buffer data. Again, GL array buffer is kind of the type of buffer that this is. Array buffer, vertex buffer, basically just means it's, I don't know, array buffer is an interesting combination of words, but essentially it just means vertex buffer in this case. Just a buffer of data. Size will be the size of vertices. So this basically requires the size of this data in bytes, okay? So you could do size of float times 9 or whatever if you want. Size of vertices will also give you that same amount of bytes, right? That same size, because this is just a stack array. The actual data, which is vertices, then the usage. So for the usage, we'll type in GL static draw, which basically just means that we're not going to be continually refreshing that array with new data. We're not going to continue kind of uploading more and more data every frame and kind of, replacing that data. We're not going to be streaming it or anything. We're going to set this up once in the constructor, and that's kind of it. So it's static data. Okay, cool. And then the last thing we need to do is actually tell OpenGL what the layout of this buffer is. Because, it's great that we can see that it's clearly 3 different kind of 3 component float vectors, right? Like 3 vec3s, essentially. OpenGL doesn't know that. It just sees it as a bunch of bytes. So we need to tell it what's up. So the first thing we'll do is GL enable vertex attrib array, which basically says we're going to enable kind of index 0 of our data. You'll kind of see where this goes in a minute. And then vertex attrib pointer. I always forget this. What is it? Attrib. Oh, that's good. I got it right. This is testing my OpenGL skill. So index 0, right? So we're basically providing a vertex attribute for the shader so that it can read this data. And we've basically enabled index 0, and this is index 0. So we're describing the data at index 0. So there's 3 floats essentially. So we write 3 floats. They're not going to be normalized because, well, they're floats. Normalization is for something else that we'll talk about later. The size here, the stride here, is going to be basically the amount of bytes between vertices. So each one of these is a vertex. Now clearly we've just got a vertex position in this case, we've just got a position. That's our entire vertex. So we just have 3 floats, 3 times 4 essentially, which is 12 bytes. So we'll write 3 times size of float. That's our stride. So that's kind of the amount of bytes between different like vertices. And then finally for, it says pointer, we just put null pointer in. This is essentially the offset of that kind of attribute specifically. Now we only have one attribute, the offset's always going to be 0. Basically that just means that when I get to the next vertex, where does this attribute begin? It begins at byte 0 because that's just the beginning of the vertex. That's all the data we have, just the position. Okay, I think that's it. So that's what we have to do for our kind of vertex buffer. So we've basically created 3 vertex positions and then kind of described them to OpenGL, as well as also uploaded them to the GPU here. All right, now we need to create that index buffer. So we'll do GL gen buffers. Let's see, so we'll generate 1 index buffer. We'll do bind buffer. Now this time it's going to be element array buffer. Element array, so I call these index buffers, really they're, I guess technically if you were being like all purist OpenGL, you call them element buffers, not index buffers. An element buffer and an index buffer is the same thing. Most people call them index buffers. In DirectX they're called index buffers, but you know, OpenGL calls them element buffers. I don't know why. They just wanted to be different or whatever. I'm not even sure the history of this. I'm not sure. I'm not going to say what's the correct way of saying it, but most of the industry refers to them as index buffers, so that's what I call them as well. It's what I'm used to. So we'll bind that buffer. Basically, it's just a buffer of like vertex, like it's a buffer of indices, which basically are indices. It's like an index into this vertex buffer. So it tells you kind of what order to kind of draw these vertices in to fill this triangle. So clearly we kind of, if we go back to this for a second, we clearly kind of want to draw, you know, this one first, right? And then this one second, and then this one third. So you can see kind of, it's like an index into an array. We kind of go over here. We say we want to draw this one first, so it's index 0, then 1, then 2, right? If we had another triangle, we'd keep going. You can also reuse vertices. So if I wanted to draw a square, and I wanted to have kind of, this was like the rest of my square, and this was index like 3, then essentially what I could have is 0, 1, 2 to draw that triangle, and then 0, 1, 3, except I'd probably do 0, 3, 1, because it's anti-clockwise, to draw that, okay? And if I kind of had those indices in my vertex buffer, I would only need these 4 points, but I could draw a square, okay? Because I can reuse vertices, but more on that later. So over here, we'll create unsigned int indices. You can use shorts or anything like that. Usually ints are pretty much the way to go there. Because you'll probably never run out of indices in that sense. We'll have 3 of them, and that'll just be 0, 1, 2, okay? Because we just have 3 points in our triangle, that's it. We'll do GL buffer data, same thing as we did with our vertex buffer, except this time it'll be GL element array buffer. Not that. Size is going to be size of indices. Data is going to be indices. And usage again, static draw. All right, sweet. So that's pretty much it. I'm just trying to think if I've missed anything. I don't think so. I mean, we'll see if this works and we'll debug it. Because obviously I haven't really tested this. But that should be good. So if we go down to what we actually have to do every frame now, really all we have to do is bind that vertex array, which is vertex array, and then we just call GL draw elements. So again, it's called draw elements because elements are our indices, right? So in DirectX, it would be called draw indexed, but in OpenGL it's called draw elements because they call indices elements. All right, so we have GL triangles is our mode. It's kind of how we want to draw these indices. Count how many we want to draw, 3. The type's going to be GL unsigned int. And then the indices, this is a pointer to them. We're going to go with null pointer. The reason is we're not providing an explicit index buffer. The one that is kind of attached to our vertex array, which should be this one, right? Because we had the vertex array bound when we created and bound this kind of index buffer. Vertex arrays kind of retain that state, so we should be fine. So now if we just run this, we should see a triangle on the screen. Let's just see what happens here. All right, check this out. So we have a triangle on the screen. That's pretty cool. And as you kind of saw, what I kind of described and what I drew in this little diagram of mine is pretty much what you see on the screen, where, this is a kind of negative 0.5, positive 0.5, and positive 0 as far as x is concerned. And there you go. Wonderful. We've drawn our first triangle in Hazel. That's pretty exciting. Now, I did want to mention that we don't actually need this bind vertex array because clearly we've bound it kind of here, and we've left it bound, but I just wanted to be a little bit more explicit. Yeah, I mean, hopefully this made sense. Again, you can see that we don't need a shader. It's just going to give us a white triangle by default, contrary to popular belief. You don't actually need a shader to render stuff in modern OpenGL, and we are dealing with a core profile, by the way. And this should work with pretty much all graphics drivers. If it doesn't, let me know. I don't have any AMD hardware to actually test on, but I'm not sure if that may be problematic. Anyway, you obviously want to ideally delete these things from the GPU when you're done with them. And there's a lot of, I mean, this is not code I would really ship, but that's not the point. The point is just to draw a triangle in Hazel, and then now you kind of see what we need to do. Vertex arrays need to be kind of moved into classes. So does all this kind of buffer. We need to create an API out of it so that we can do all this stuff in a better way. The index buffers as well need to be moved into its own thing. The renderer would handle things like clear color and the actual clearing. Although, clear and clear color are things that eventually would make themselves to the actual render target or frame buffer that you were actually using. And then draw elements, again, is something that you do with the renderer. So you tell the renderer, I am submitting this draw data, please draw it. And then the renderer itself would call GL draw elements to actually draw that stuff. So this is all kind of stuff that eventually gets abstracted out into its own classes. But now we have an overview so that we can actually begin doing that, which is pretty cool. And obviously we have like a test bed of what we actually want to do. What I mean by that is instead of us just building classes, then at the end of it, oh, hey, a triangle, we kind of have a triangle and we can work backwards. And I'm kind of a big fan of that. Because getting stuff up and running quickly is always a good thing to see if it even works in the first place. And also it's just kind of more motivating and just better to kind of be like, oh, look, a triangle. And also as we do this over time, we'll remove vertex arrays first, for example, then buffers. I'm not sure which order we'll do it in, but suppose that was the order. We do it one step at a time, and then we keep checking and testing. Is our triangle still there? Oh no, it's gone. Clearly we've made a mistake. So that's another very kind of good way to actually work. Okay, cool. I wanted to do something else. Yeah, so I wanted to actually show you guys how we can see what graphics driver we have. So if we go into our OpenGL context class, what I'm actually going to do is when we've actually made the context current and we've initialized this stuff, I actually want to GL, I think it's get string GL vendor or something like that. I might have to Google this, but essentially what this should do is actually let us know, and we'll do an hz core info or something. This should actually tell us, I might say OpenGL, renderer. This should actually tell us what GPU we're using, basically what driver we're using. So if I just kind of run this code, maybe that will work. Again, this is completely off memory, so if I'm wrong, I'm wrong. But we'll see. Where's our console? Here it is. Okay, so it just says OpenGL renderer Intel. So that's not that useful. I'm not sure if there's a better way to do that, maybe by an actual version number. Usually it says kind of what it is, but I guess that's just the vendor I've asked for. Let's see if there's this GL renderer, there's GL version. So OpenGL renderer, maybe I'll do that. And 1, so let's see what this does. I'll probably move this into it. I'll probably format this a bit nicer in a second, but I guess I want to see the renderer as well. It's just reusing that console window. Okay, so there we go, Intel and then Intel HD graphics 530. Okay, cool. So this looks pretty good. So what I'll do, just to clean this up a little bit, is I'll kind of do OpenGL renderer, and then I'll probably do hz core info, maybe like 2 spaces, and then vendor, and then we'll kind of do vendor, renderer, and then version. Okay, just so that we get some basic OpenGL kind of info here. So we'll do vendor over here. We'll do version down here. aperture version, and then, you know, renderer will move as well. OpenGL info or something like that. Okay, cool. And this is kind of just a quick, crude way of doing it, but it should give you pretty much everything you need to know in just a really quick kind of easy way. So let's just run this again. Man, these compile times are already, like, look at this. Visual Studio's already kind of, oh, it's because I've got that selected. Okay, so there we go. Okay, aperture first. So we have vendor, Intel, renderer, and then version 4.4. Awesome, okay? So that's the kind of stuff that we get with that. And then what I can do, and what you guys probably should do, is if you go into your Nvidia control panel, you can just right click on your desktop and then hit Nvidia control panel. And if you go to manage 3D settings, then program settings, you can add that kind of hazel thing here. So I'll add that. And then I'll just make sure that it uses the high performance Nvidia processor, for example. I'll hit apply on that. And then once that actually does apply, if I run it again, it should actually use my Nvidia GPU instead. So if I run this again, we go back to this, you can see that now it says Nvidia Corporation, we're using Untitled 4.6 instead of 4.4, and you can see kind of what card it's using as well. Okay, so if this does not work for you, then now that you have this extra code in your context class, just basically come over here and just, you know, copy this and just paste it in a comment, and we'll see kind of what drivers are problematic with this. But as far as I know, this should be pretty solid in kind of modern-ish hardware. So maybe if you're using hardware from 10 years ago, it's not a thing, but I think that this kind of example should work for most people. Anyway, I hope you guys enjoyed this video. If you did, you can hit that like button. You can also help support this series by going over to patreon.com/the Cherno. As I said in the beginning of this video, it's a really great way to support the series. I'm super thankful to all the people who actually do make this possible. And yeah, like if you want kind of more advanced code than this and you don't want to wait week to week as the series grows, then I've done a lot more stuff there. Cool. This is pretty exciting. Our first triangle in Hazel is now live. I will upload this code to GitHub, as I do kind of at the end of every episode, so you can check it out and run it on your computer. And as I said, you can just kind of see if it works. Next time we're going to kind of start, well, there's two things that we could do next time. And since I'm not making an episode early for patrons this week, I can just ask you guys and see what you want. So we could either create a shader and just add a shader to this and make the triangle like red or something like that, and kind of go through how we're going to add a shader to that. Or we can just start abstracting this stuff out. Adding a shader would be nice because it just means that we can kind of have a full picture of what to abstract, and then we can do a lot more kind of cool things, I guess, with that. But if you guys don't want to see that, if you guys would rather we get to the abstraction faster and kind of just create that render and build up that rendering API as soon as we can, then we can also do that. Choice is yours. I might do a YouTube poll, actually, because that's the thing, right? I'm not sure if it's still a thing. I might either do that or just kind of leave a comment below and just upvote comments that are saying the thing that you want. And, you know, I'll kind of read them in a couple of days and see what we need to do. All right, thanks for watching. I'll see you guys next time. Goodbye.